Rallying can be tracked back to the 1894. This event led directly to a period of city-to-city road races in European countries, and now it becomes one of the most popular motorsports games all over the world. Rallying is a form of motorsport that takes place on public or private roads with modified production or specially built road legal cars. It is a point-to-point format in which participants and their co-drivers drive between set control points, live at regular intervals from one or more starting points. Rallies may be won by pure speed within the stages, or alternatively, by driving a predetermined ideal journey time within the stages. In this project, we want to use Six Sigma tools to improve the performance in a rally game, Dirt 4. It can be divided into 5 steps, DMAIC. First of all, to find the critical to quality, no doubt about that, it is the racing time. The shorter time means better quality. Then, the sources of variation should be determined. In our study, we try to find out the influence made by transmission, ABS, stability control, the type of the car, and the environments. Different combination of these sources of variation may influence the performance of the car. Next, let's conduct detailed experiment to quantify the different settings. We have set totally 12 groups of experiment, 26 times of races, covered all variations to study. Every single race is about 4 minutes, running by an experienced player. The exact racing time of each race will be recorded. Based on the data recorded, we use Minitab to draw some plots and then to analyze. From the Pareto chart, we found out that the environment, transmission, and stability control are the most significant factors among all the factors. In the effect plots, a factor means an independent variable in an experiment whose state can be varied. Now we can see the relations between changes in level of each factors and the changes in response. When we use a longer transmission, the racing time reduces. But, which is interesting, using higher level of ABS and stability control will slow down the car. As for the environment, it's obviously that running at a cloudy day, a better performance can be achieved. Other conditions will make your racing harder and harder, especially during a rain. After that, we have a residual plots for time, which provides graphs to check if the data is nicely fit the regression equation. We can see that the residuals are normally distributed with a mean of 0 and a constant variance. Therefore, there's insufficient reason to reject the model. P-values of all the sources are calculated as well. From the results, the p-values of transmission, environment, and stability control are smaller than 0.05. This means these results are more reliable. Minitab is such powerful software that we can get a generated equation of all the factors. That seems a little complicated. So let's look at this. An optimized solution to get a minimum time was given as well. It means if I set all parameters at the given level, I possibly can get a best performance in the game. That's very exciting. To examine this method, we will do another experiment. Set all the settings at the given solution and then play the game for 10 times. With these results, we drew a control chart to evaluate the effect of improvement. Look at the great change we have done. The mean time decreased to 4 minutes and 1 second. In the individual value chart, most points are in the control limit, and in the moving range chart, all points are in the control limit. Finally, we can conclude that after improvement, both performance and stability of the racing grid are better.
Right 5 and left 6 and right 6.
So, do you know how to perform better in Dirt 4?
Left open jump maybe, left 4 through dip, 60.
At last, I would like to express my appreciation to Professor Ji for giving such practical lecture. I have learned a lot of methods and knowledges for my future career. Thank you.